Cabling is pretty much the heart of any modern day network. If you don't have things connected together, they can't possibly share data and do all the other cool things that networking allows. So there have been several types of cable created over the years for various purposes. Back in the 80s, you always remember that, right, Drew? Early networking adopters used coax. Yeah, the coax cable actually used what they call vampire connectors.
Oh.
You ever heard of them?
Yeah.
I've actually seen
where the
them.
one goes like down past the shield, and it's supposed to have that insulation thing that keeps the shield from touching the center conductor, but those break all the time, so you just want it for the short, and then you have to hunt down short.
Yeah, so you can see where that is a problem with keeping the network up and
Cable
running.
TV, right?
You what?
It's like those cable TV connectors. Those are coaxial.
Yeah, that's same type of cable, but that is end to end with the coax in early networks that they use token passing. So every time you just had a main trunk line, and every time you needed to add a computer, you just put one of the vampire connectors on the cable and
Clamp it.
tapped off of it, run it to the computer. So, voice grade, category 1 cable will transmit up to 1 megabit per second of data. So, really slow by today's standards. They came up with category 2, Cat 2 cable, raised it up to 4 megabits, but that was really short-lived. Short-lived. It was a matter of just a couple of years in category 2 went away. So, early 90s, Cat 3 came out, raised the bar even further. Frequency of 16 megahertz, could do up to 10 megabits, which was the original Ethernet. Cat 3 was widely used for 10 base T Ethernet applications. So the 10 in 10 base T is 10 megabits. Base is baseband, which tells you about the type of communication that goes through. Cat 3 was used a lot in telephone networks also. Cat 4 cables made a brief appearance, increased the performance up to 20 megahertz, 26 megabits. Most of these are token ring. And then in 95, Cat 5 cable was introduced.
Yay.
Produced, I lost mine. Oh, provided 100 megabit speeds with 100 megahertz bandwidth. Could send data packets up to 100 meters or 328 feet without amplification. If you need to run farther than 100 meters, you can, as long as you're not very much farther, 105 maybe, but you get much farther than 100 meters and the signal degradation goes down so much that it makes the error rate too high. So you had to put in some kind of amplifier.
Mhm.
They do make signal repeaters. The other thing you can do is just throw in a 2-port hub where everything comes in, goes back out, but it's amplified. You can put a switch in, but that's kind of overkill for the signal amplification. Cable's capabilities were a big leap forward, but they pale in comparison to what came next. Cat 5e, or Category 5 enhanced cables. Improved version of Cat 5 was able to push the data transfer rate to 1 gigabit, which is 10 times faster than the previous 100 megabits. Even though this type of cable is more than 20 years old now, it's still very popular and widely used.
So true.
And I meant to look at these and see which one I actually grabbed from upstairs. Put my eyeballs on here real quick. Cat 5. Cat 5e, sorry. So the cables that we're going to make today are Cat 5e. So put them in your network at home, turn them up to gigabit. Category 6, starting to show up more and more, offers speeds up to 10 gigabits, 250 megahertz. With improved crosstalk protection. You guys know what crosstalk is?
Mm-hmm. When you have the emissions from your cable interfering with other emissions from another cable, they conflict.
Oh, electromagnetic interference, or in other words?
Basically, yeah.
Yeah, basically.
As the signal propagates down one cable through magnetic induction, it actually transfers the signals to adjoining cables or conductors within the same cable, actually.
Without coming in contact?
Yeah.
It's just like a transformer, you know,
Yeah,
there's
right.
like windings.
Yeah, and that's basically what it is, yeah.
Electromagnetic fields going.
Yeah. That's why, yeah, there you go, piece of. Well, here, let me get it. That's the reason why the Ethernet cables are constructed the way they are. You look at the individual pairs, you can see that they are twisted at different twists per inch. That helps eliminate crosstalk between the pairs.
And this one is not shielded, right?
No, it is unshielded cable, yeah. Cat 6 only supports 10 gigabits up to 55 meters or 164 feet, so roughly half of what the Cat 5e is good for on the 1 gigabit. Cat 5e and Cat 6 began to become part of the bottlenecking network as internet connections become increased or continuously faster, both home and office environment. How many of you guys have internet service at home? How many of you guys have at least 1 gigabit Ethernet, 1 gigabit internet service at home?
My internet, I just know my internet's fast. I forget, I think it's the measurements.
It's fast.
No.
How do you watch YouTube?
Well, Nick didn't get to see it.
That's crazy. You probably go through so
It
much.
works perfectly. No, actually it works perfectly.
It works perfectly, but your phone goes like $9,000 a month.
Augmented category 6 supports the same 10 gigabit, but it can do up to 100 meters, 500 megahertz. Cat 6A cable is stupid expensive.
Cat 6A.
Imagine.
I mean, it is stupid expensive. It's like $5 a foot. Yeah, stupid expensive. But if you need those kind of speeds for longer distances, at that point, you want to seriously consider going fiber optic because that's a lot cheaper.
That's what everybody's doing now.
Right?
Cat 7 never superseded Cat 6 since it was neither of the governing bodies that approved the standard, EIA, TIA. I don't remember what those two stand for. We can look it up if you want to.
Yeah.
You can read.
Yeah, that's what they stood for, so I said EIA.
Yeah. Yeah, and TIA. The twins. If Cat 7 cable is used with Cat 6A modular plugs, cable will have better performance. Realistically, 6A is a better choice and is supported official standard. Cat 7 supports the same transmission speed and distance as 6A, but good for 600 megahertz instead of 500. Category 8 have Cat 8 1 and Cat 8 2 in Class 1, Class 2. Recommended for data center environments. High-speed switch-to-switch and server communication, 25 to 40 gigabits on copper.
Yeah, 40 gigabits per second, that's like 8 gigabytes per second, right? Is that how it works? Or no, it'd be 5, that's like 5
I've seen this video.
gigabytes per second.
I've seen this video and there's this guy he's downloading the new Black Ops 6 and it's like, I don't even know how big it is, but it's big. And
Yeah, hundreds of gigabytes.
yeah, it's like 300 gigabytes just to download. And when he was downloading it, he had like 1,000 terabytes per second just going through his computer.
What? Okay.
And I was like, that's impossible.
As
And
you
it,
see,
and it actually
I
worked.
think we're
That was definitely not. Best you can do is 40 gigabits.
Yeah.
I was like, there's no way. It said terabytes per second.
The only major difference between Cat 1 through Cat 7 and Cat 8 is Cat 8 uses a completely different connector. Cat 8 is not backward compatible with the other ones where
Oh, really?
everything else is backward compatible. So there's a chart that shows the different categories and their speeds. You don't get into shielded cable until you get up to Cat 5e. Cat 5e is available in UTP, unshielded twisted pair, and STP, or shielded twisted pair.
So what is mostly used in like these communicating with these PLCs, like those ones?
Well, the teal colored cables that you see on there that are from Rockwell are shielded, and they're all Cat 5e. Yeah, there's one.
Seems like those are a good kicker.
Bro, how did I get all the way to level 83? No problem.
If you look at, this is a shielded cable, you can tell that it's got the,
Oh, okay, the metal,
yeah, that's for the shield connection.
oh.
Yeah, we learned about this in PLC team. Oh, but this one, I'm gonna crank real hard on this one, it's broken.
Yeah, that's not surprising.
Oh, I had to do it. I just put it.
Okay, so
They removed.
how is this for a bunch of different types?
Really, that's interesting.
UTP is the most basic one. Unshielded twisted pair, it's just the twisted pairs and the outer jacket, nothing special about it. Then you got the STP, shielded twisted pair. You have each pair twisted together. Then there's an outer.
What is that drain? Isn't that, drain where?
That's where, the way the drain works, it is in physical contact with the braided shield. And that's what you connect to your, ground plane.
Oh, so that's why that metal shield is coming out of.
Yeah, the main reason for using, shielded cable is in an industrial environment where you have a lot of electrical noise, especially whenever you have VFDs running motors, because they are basically giant radio transmitters.
Oh, yeah.
Oh,
So they use
And
filters for those, right?
yeah,
Put
the,
it in line.
any motor that's being run off of a VFD is supposed to have VFD rated cable, which it in itself is actually double shielded. Actually double shielded. And most cases, you only hook the shield up on one end or the other, because you're trying to capture any outside interference from getting to the cable. If you have it connected on both ends, it's just another conductor.
Right, yeah.
If you only have it connected on one end, then it becomes an antenna that draws the electromagnetic interference to ground, keeps it from getting to the stuff that you are trying to protect, with the wires inside. With a VFD cable, you want to ground it on both ends because you're trying to create a Faraday cage to keep the noisy signals in the VFD cable from getting to the outside world.
It's also transmitting usually AC, right? AC signals.
Yeah.
Are going back and forth.
Yeah. Okay, so anyway, as you increase, you add individual shielding, whole cable shielding, all the way up to twisted pair, individual shield, double shield on your jacket and so on. You get up here into the SFTP cable, and it gets really expensive really quick too.
oh, I bet. Look at all that shielding.
Solid versus stranded. Solid, basically, less flexible, say if you're doing big, long runs like in a race duct or, all the cabling you see outside the room and in the wire tray.
Mm-hmm, it is.
That's all solid wire. It offers much better, data transmission.
But it's pain to work with.
Yeah. This cable that we're going to be using today is stranded. And it is a lot more flexible than
Mm-hmm.
the solid stuff. It,
Fiber optic, cable, what is that? Yeah. So I know you could.
It depends.
Snap it, like the
Silicon
guy that,
glass.
saw my internet, he said to be careful with it, cause you can break it.
yeah, it depends. Most of the time, a high quality cable anyway is glass.
Oh, yeah.
Well, they still use glass.
The,
It's made out of sand.
El cheapo ones that you can buy at Walmart for a couple of bucks is plastic.
They used to use glass all the time, but it kept on breaking, so that's what they went to plastic. I didn't realize they still use glass.
Yeah, it's.
But it's
still used
expensive?
It's expensive? I thought it was cheaper, huh?
Depends on which fiber you're talking about, whether it is single mode or multi-mode.
Oh, okay. Cause made from sand, it was, a part of the benefits, like a macroeconomic thing, is that instead of using, copper for wiring, which kind of comes at a limited supply, especially in like war times and whatnot, by having this fiber optic cable that is made from sand, which we have near, pretty much, we're never gonna run out of sand. You're not gonna come into some sort of shortage in materials to make cable out of.
Is fiberglass even made of sand? 'Cause it's like fiberglass strands, right?
It's glass,
So, but it is glass.
Yeah, it's all silica.
also sand essentially.
Yeah, but you have to be careful about stepping on glass
Ooh, yeah, cause that's
cables, because if you have people step on them too many times, then it breaks it.
Well, and they have a minimum bend radius too.
That probably does, yeah,
So
you're
far.
right about that. I didn't think about that, but you're right, it would have a minimum.
can't do this.
All cables have a minimum bend
Yeah,
radius.
okay, but that
Even
means-
these.
Yeah, but glass would have worse one.
There again, it depends on whether it is single mode or multi-mode.
There's another kind of fiber optic cable that allows you to bend them a lot. I saw it to where a guy was.
That's typically plastic.
Yeah, because there's a way that it sends the light beam straight up, and there's a way that sends the light beams and they bounce all over the wire to get to the end. As the light
Unless
passes
your
through-
cable is bone straight,
Yeah.
it's gonna bounce.
The signal will.
It's what is known as total internal reflection.
Oh, yeah, I've heard of that term
Yeah.
before.
The signals can kind of.
We are not going to concern ourselves with fiber optic in this class though.
Come in handy.
I mean, I was using some, I'm pretty sure that all the encoders now, that's what they're also using.
I wouldn't say all.
To get a better, like, accuracy.
The beauty of fiber is it's light, and light is not susceptible to electromagnetic interference like copper is. You cannot induce noise on light.
Like,
So anyway, solid is used for permanent cable runs. And then the stranded is for patch cables where, if you're constantly flexing it and when you need to crimp one on the end of it. You can crimp the the solid, but it's a lot higher probability that the cable will be bad whenever you're finished. Because the connector doesn't pierce the conductor like it's supposed to. CCA, copper clad aluminum. Most cable that you buy online, like Amazon or places like that, is CCA rather than solid copper. It's cheaper to make. Advantages of 100% copper, no shortcuts taken during the manufacturing process. Cable is made from 100% copper and it's available in either solid or stranded. Copper cable is much better suited for longer distances because the copper has lower electrical resistance compared to the aluminum. Especially on longer connections, this can make a difference between a solid connection and a slow, flaky connection. Copper cable is much more resilient against oxidation and corrosion. Aluminum oxidizes very quickly when exposed to air. It's that white powdery substance that you see on aluminum if it's not been treated. American wire gauge, AWG. These are typically 24 to 22 gauge. You can buy even cheaper cables that are 28. Don't. They're not worth it. Spend the extra few pennies per foot of cable and get the good stuff. The slim cables, all the way down to 30, they're good for really short runs, as long as you don't intend on moving the wire for very much. So because it's so small, it tends to break very easily. No, you have to use one much shorter runs, like I said. Okay, this is what we're going to concern ourselves with the most today is the EIA-TIA wiring standards. You have two ways to connect Ethernet. The white-green green pair first, or the orange-white-orange pair first. Orange-white-orange is almost always first. That's the B standard. Okay. Straight through cabling, pin 1 gets connected to pin 1, pin 2 to pin 2, pin 3 to pin 3, and so on. That is if you want to connect your computer to a switch, to a router, that sort of thing. If you do crossover, which is A on one end, B on the other, so orange pair first on one end, green pair first on the other. You can connect two devices together with just a cable.
So you normally cannot do that under normal conditions, just take a regular cable and take
Yeah, if you try to connect two devices together with just a regular old cable, it may or may not work. It depends on the network interface card, the NIC. Some of them,
the same? Aren't all the NICs like?
no.
Oh, I mean, the ports that accept the cable are the same, but the interface inside isn't.
Yeah, it's always the same connector, but the, better NICs
Oh, I get it.
can do, automatic MDIX, which means the NIC will, figure out what type of cable is connected to it and adjust itself accordingly.
Oh, okay.
Okay, so anyway, straight through is pin to pin. Crossover, pin 1 gets connected to pin 3. Pin 2 gets connected all the way down here to pin 6. 3 to 1, 4 to 7, 5 to 8, 6 to 2, 7 to 4, 8 to 5.
So essentially, it's pretty much, whenever you're doing the cross wiring, you're trying to get, the top of figure A to rewire it and essentially put it in the ports of the bottom figure of figure A, whenever you're doing cross wiring, sort of.
Sort of.
Yeah.
That is a true crossover cable.
But as like interface cards are getting smarter, we don't need to kind of cut down the cable and do it anymore. We just plug it in and the NIC should do the rest. That would save us time having to cut the cable and cross-referencing them. So companies are probably like, hey, we just need to.
Yeah, any modern NIC is going to be capable of automatic MDIX.
This was probably done a while back.
Back in the day.
And now
Yeah,
it's,
back in the day.
but I mean, we still need to know.
You still need to know the fundamentals.
Yeah, also, for 100 megabit Ethernet, 4 and 5 and 7 and 8 are not used. So you can just cross 1, 2, 3, and 6. If you're doing gigabit, then you have to cross all 8 of them. Okay. We are not going to do crossover cables when we do make our cables today.
Oh,
It's all going to be straight through.
Yeah, straight through is hard enough.
Um, Media and media converters, fiber optic cable, single mode versus multi-mode. Single mode fiber means that it enables one type of light mode to be propagated at a time. Multi-mode can propagate multiple modes. The difference between single mode and multi-mode mainly lies in fiber core diameter, wavelength, and light source, bandwidth, color sheet, distance, and cost. Single mode fiber core diameter is much smaller than multi-mode. Typically has a diameter of 9 micrometers or microns.
tiny.
That's like,
It'd be very, very tiny.
that's how big a fiber optic cable is?
The actual
Yeah.
fiber itself, yeah.
Why does it need to be so small? Couldn't it be like bigger?
Well, the multi-mode fiber is 50 micron.
Oh, okay, yeah.
It has to travel.
50 microns, that's so much bigger than 9
Yeah.
microns. So, yeah, that makes sense.
That's what, 5 times bigger?
I was thinking it was like, as big around as like a pencil lead or something.
I was figuring.
That includes the outer jacket and everything.
Wow.
Size of a hair.
Yeah.
But you gotta figure that the light is, itty bitty, teeny tiny photons that you can't see with your naked eye, so. You can still grab a whole bunch of them in 9 microns. Attenuation of multi-mode fiber is higher than that of single mode because it has a larger core diameter. Shielded, twisted pair, and unshielded, 2 types of copper cabling used to transmit data. Both share similarities in design but differ in terms of construction and performance and their optimal environments for use. Shielding, obviously shielded, STP has a shield, but UTP does not. STP performs better in environments with high levels of interference, such as industrial near heavy machinery or building with a lot of electrical noise. UTP performs adequately in environments with minimal interference, such as offices and homes. Cost, STP is more expensive to produce and install due to the added shielding and needed proper grounding to ensure the shielding works effectively. UTP is cheaper to manufacture, purchase, and install. STP requires careful installation. Improper grounding can result in performance issues or even create noise problems. UTP is easier to install, more flexible, doesn't require grounding. STP is thicker and less flexible due to the shielding, making it harder to bend or fit into tight spaces. UTP is slimmer and more flexible. Similarities, both STP and UTP use twisted pairs, copper. Twisting wire that helps reduce electromagnetic interference and crosstalk. They both use RJ45 connector. Both of them are used to transmit data in networks supporting various network standards, such as Ethernet. When comparing equivalent categories, Cat5, Cat5e, blah, 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 STP versus UTP, they both have the same frequency limitations and whatnot. Typically used in environments where there's a lot of external interference. And UTP is widely used in homes, offices, data centers, blah, 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 blah. Okay. Questions?